Imagine taking a giant knife and carving a clean, jagged tear straight through an entire continent on Earth. That cut would stretch all the way from New York City to Los Angeles, cutting deep into the rocky crust below. It sounds like pure science fiction, but this massive scar is completely real. And right now, as you listen to these words, high-resolution cameras orbiting Mars are mapping sections of this monster gorge that go down so far, sunlight barely touches the valley floor. If you love exploring the quietest, most mind-bending corners of our solar system, with real science and zero sensational hype, hit the subscribe button right now. When you join our community, you will always be the first to know whenever our robot explorers make another shocking breakthrough on distant worlds. For over a century, humans looked at the red planet through small glass telescopes and saw a dry, silent ball of red dust. Most people assumed it was a dead world where nothing ever changed, just an endless sea of cold sand and gentle craters. Early astronomers drew blurry maps by hand and argued about fuzzy lines they thought they saw on the rusty surface. Some even believed there were artificial canals carrying water across dying cities. But everything we thought we knew about Mars began to crumble the moment we sent our first robotic orbiters to take close-up pictures of its barren surface. Back in late 1971, a small spacecraft named Mariner 9 reached Mars during a massive planet-wide dust storm. For weeks, the orbiter could not see anything through the thick orange clouds that wrapped around the entire globe. Giant dust storms on Mars can swallow the whole planet for months at a time, hiding every single mountain and plain from view. Scientists back on Earth waited anxiously, wondering if the spacecraft would run out of fuel before getting a single clear image. But when the dust finally settled down, scientists at NASA looked at the first clear photographs and could not believe their eyes. Sitting right along the Martian equator was an enormous system of canyons, so massive that it made every single valley on Earth look like a tiny crack in the sidewalk. NASA named this entire canyon network Valles Marineris, in honor of the brave little spacecraft that first spotted it through the clearing dust. It spanned thousands of kilometers across the planetary disk, looking like a giant gash cut into the side of the planet. For decades, scientists studied the main sections of this canyon, thinking they had mapped out all of its biggest secrets and understood its basic shape. Yet recent satellite scans, powered by ultra-high-resolution cameras on orbiters like the Mars Reconnaissance Orbiter and Europe's Mars Express, have revealed hidden side chasms and buried sub-canyons that are far deeper and more violent in origin than anyone had previously realized. Some of these interior drops plunge over 7 kilometers straight down, which is more than 23,000 feet into the Martian crust. The sheer scale of these abysses makes them genuine wonders of our planetary neighborhood, dwarfing any geological feature found on our home planet. To put that number into perspective, Earth's famous Grand Canyon in Arizona reaches an average depth of around 1 mile, or roughly 1.6 kilometers. That means this Martian chasm is more than 4 times deeper than the Grand Canyon, and in some specific fracture zones, it is nearly 5 times deeper. If you stood at the very bottom of the Grand Canyon on Earth, you would feel tiny looking up at the rim. But if you stood at the floor of this Martian gorge, the towering rock walls would reach all the way up to the cruising altitude of a commercial passenger jet flying through the upper sky. Let that sink in for a moment. You could take the entire Grand Canyon, drop it right into one of these side trenches, and it would vanish completely beneath the shadows of the canyon walls. It would look like nothing more than a tiny ditch sitting at the bottom of a giant mountain range. The vastness is difficult to hold in the human mind because we simply have nothing on Earth that matches this scale. If you were standing at the edge of the rim, the opposite cliff wall would be so far away that it would curve down over the Martian horizon, making it feel like you were standing at the edge of an infinite world. The total length of this gigantic rift system is more than 4,000 kilometers, which translates to roughly 2,500 miles across the Martian surface. If you place this system across the United States, it would stretch from the Atlantic coast of New York all the way to the Pacific coast of California. It is wide as well, opening up to 200 kilometers across in its broadest central basins, meaning you could fit entire states or small countries inside the valley floor without touching either cliff face. Have you ever visited the Grand Canyon in person or stood at the edge of a massive cliff on Earth? Drop a comment below and let me know how it felt, and make sure to hit the like button if you want to see what happens when we push even deeper into this alien abyss. When geologists first began studying Valles Marineris in the 1970s, they naturally tried to compare it to the geological features we see on Earth. Most scientists expected that, just like the Grand Canyon, this Martian canyon was carved out by a raging river that slowly wore down the rock over millions of years. That made sense to researchers at the time because water erosion is the #1 way deep valleys and river gorges are formed on our home planet, grinding through solid rock grain by grain over vast stretches of time. However, when scientists looked closer at the chemical makeup of the rocks and the sheer shape of the canyon walls, that initial theory fell apart completely. Water definitely played a role in shaping small parts of Mars later on, but it was not the main force that ripped this giant chasm open. The canyon was simply too wide, too straight, and lacked the branching river networks and delta deposits you would expect from a slow, steady river system. The real cause was far more violent, and it all started with a massive volcanic explosion from beneath the planet's surface. Long ago, when Mars was still young and full of intense internal heat, a giant plume of molten rock rose up from deep inside the planet. This hot magma pushed upward with unimaginable force, bulging the Martian crust into a massive volcanic plateau known as the Tharsis Bulge. This volcanic region grew so heavy and so high that the rocky skin of Mars simply could not hold the immense weight anymore. It rose miles above the average surface level of the planet, creating a giant swell that stressed the entire global crust. Sitting right next to the canyon are some of the largest volcanoes in the entire solar system, including Olympus Mons, a shield volcano 3 times taller than Mount Everest. Alongside Olympus Mons sit 3 other monster volcanoes known as the Tharsis Montes, which tower over 14 kilometers into the Martian sky. As these monstrous volcanoes erupted repeatedly and spewed billions of tons of heavy basaltic lava onto the surface, the crust underneath began to sag, buckle, and pull apart under the colossal downward load. The outer crust stretched, cracked, and snapped like a dry wooden branch under immense tension. As the ground pulled apart, huge blocks of rock dropped straight down into the crust, creating a giant rift valley thousands of miles long. It was not a slow, gentle carving by water, but a catastrophic structural failure of an entire planetary crust that tore the planet wide open. Geologists call these dropped blocks grabens, and they form the flat, sunken floors of the deepest chasms that we see today. This is where the story gets even stranger. In recent years, advanced radar instruments capable of peering beneath the dust have shown that beneath the visible floor of the canyon, there are even deeper hidden fractures filled with layered sediments and mysterious minerals. These hidden basements tell a story of a planet that was once dynamic, violent, and active in ways we are only now beginning to piece together. Planetary scientists are finding that the rift did not just stop after the first crack, but continued to evolve for hundreds of millions of years. Scientists originally thought that after the initial ripping of the crust, the canyon remained a dry, frozen wasteland for billions of years without much activity. But high-resolution stereo cameras have detected massive landslides and giant fields of dried sulfate salts inside the deepest trenches, such as Candor Chasma, Ophir Chasma, Melas Chasma, and Coprates Chasma. These individual chasms are like massive worlds of their own, each with distinct rock structures, unique geological histories, and mysterious landforms that look unlike anything on Earth. These mineral salts are a huge clue because on Earth, sulfate salts only form when liquid water interacts directly with rocks over long periods of time. This means that long after the crust split open, ancient lakes and deep groundwater reservoirs filled up the lowest floors of the canyon, creating temporary water worlds deep beneath the surrounding plains. These were not tiny puddles, but deep, standing bodies of water that lasted for millions of years, fed by underground aquifers that burst through the fractured rock walls. Imagine looking down into this colossal valley billions of years ago and seeing vast, shimmering lakes trapped between cliff walls that reached higher than the highest mountains on Earth. Sunlight would bounce off the surface of these ancient Martian seas, reflecting against red volcanic rock faces and towering waterfalls that poured down from the upper plateaus. It completely changes how we view Mars, transforming it from a dead ball of rock into a world that once held vast bodies of water in its deepest shadows. Think about that for a second. If you were looking for signs of ancient alien life on Mars, where would you go? The dry, windy surface above, or the bottom of a protected, mineral-rich canyon where water once pooled for ages? Tell me your thoughts in the comments section, and if you are enjoying this deep dive into Martian geology, consider sharing this with a friend who loves space. The deeper scientists look into these canyon walls, the more layers they discover. In geology, rock layers are like pages in a giant history book. Every single layer of dust, lava, and mud tells a story about what the climate was like when that layer was deposited. On Earth, we can look at the walls of the Grand Canyon and read roughly 2 billion years of our planet's history, preserved in neat, horizontal stripes of sandstone, shale, and limestone. On Mars, the story is even older and far more pristine. Because Mars does not have active plate tectonics like Earth, its crust does not get recycled back into the mantle through subduction zones. On Earth, continents collide, mountains rise, and old rocks are melted back down into magma, erasing ancient history and destroying old fossils. But on Mars, the exposed cliffs of Valles Marineris contain rock layers that have sat completely undisturbed for 3 to 4 billion years, offering us an untouched window into the birth of the solar system. When the Mars Reconnaissance Orbiter zoomed in on these cliff faces using its specialized spectrometer camera, it noticed something unexpected. The layers were not all made of the same uniform volcanic basalt. Instead, they alternated between hard volcanic lava flows, soft ash layers, and thick beds of hydrated minerals and clays. Each distinct stripe represents an entirely different era in Martian history, showing times of violent volcanic ash fallout followed by calm lake deposits. This means that ancient Mars went through dramatic climate shifts, swinging back and forth between explosive volcanic eruptions and periods of wet, watery calm. Each layer is stacked neatly on top of the other, reaching thousands of meters into the sky. If human astronauts ever climb down those cliffs, they will be walking backward through billions of years of planetary evolution, with every single step they take downward into the dark, reading the story of a dying world written in the stone. To make things even more dramatic, these cliffs show evidence of the largest landslides ever recorded in our solar system. When the canyon walls gave way, entire mountain-sized chunks of rock collapsed and slid across the valley floor at speeds exceeding hundreds of miles per hour. The debris fields from these ancient slides spread out for tens of miles, creating giant, wavy ridges of shattered stone that remain perfectly preserved today because there is no rain to wash them away. Scientists believe that some of these massive landslides may have been lubricated by underground pockets of trapped water or ice. As the heavy rock gave way under the pull of gravity, the friction heated the trapped ice, turning it into slick mud and allowing millions of tons of stone to glide effortlessly across the flat valley basin. The sheer violence of these events would have shaken the entire planet with massive Martian earthquakes, sending shockwaves through the crust for thousands of miles. The geometry of these landslide deposits gives researchers critical clues about the strength of the Martian crust. By analyzing the angle at which the cliffs sheared off and the distance the rubble traveled, geologists can calculate how dense the rock was and how much internal pore pressure from water existed inside the stone before the collapse. Every single landslide scar is a frozen laboratory that reveals the hidden moisture levels of ancient Mars. Right now, as you listen to this, planetary scientists are using complex computer simulations to study how atmospheric pressure behaves at the very bottom of these extreme trenches. The surface of Mars has an extremely thin atmosphere, with less than 1% of Earth's atmospheric pressure at sea level. If you stood on the high plains of Mars, the air would be so thin that liquid water would immediately boil away into vapor, even if the temperature was well above freezing. Did you know that the air pressure changes drastically depending on how deep you go into a canyon? If you have ever felt your ears pop while driving down a steep mountain road or flying in an airplane, leave a comment below describing your experience, and don't forget to like this video to help more people discover the secrets of Mars. At the bottom of a 7-kilometer deep canyon, the physics change dramatically. Because the canyon floor is so far below the average surface level of Mars, the weight of the air column above it creates a localized pocket of higher atmospheric pressure. It is still too thin for humans to breathe without a pressurized spacesuit, but it is significantly thicker than anywhere else on the planet's surface, reaching nearly double the pressure found on the surrounding plateaus. This localized increase in air pressure changes how heat, wind, and frost interact with the ground. In the early morning hours on Mars, thermal imaging cameras on orbiting satellites have captured thin veils of water ice fog rolling through the floor of these deep chasms. As the sun rises and warms the high canyon walls, the trapped cold air at the bottom creates complex wind systems that blow dust and frost along the valley floor like an alien weather chamber. Scientists are now discovering that these unique microclimates might actually protect the valley floor from the harsh space radiation that bombards the rest of the Martian surface. The surface of Mars is constantly struck by dangerous cosmic rays and high-energy solar flares because the planet lacks a global magnetic field and a thick ozone layer. But the towering rock walls act as giant physical shields, blocking radiation from the sides and significantly reducing total exposure at the bottom. This makes the canyon floor one of the safest natural environments on Mars for future human exploration and permanent settlement. If humans ever establish a permanent research base on the Red Planet, building habitats inside these deep, sheltered chasms could provide natural radiation protection, higher air pressure, and easier access to underground water ice without needing to bury habitats under feet of artificial concrete. The microclimate inside the canyon also creates unique wind patterns that sculpt the landscape in unusual ways. During the day, warm air rises up the sunlit canyon walls, creating powerful updrafts that lift fine dust particles high into the atmosphere. At night, the temperature drops rapidly and cold, dense air rushes down the cliffs, creating katabatic winds that sweep across the valley floor, polishing the rocks and carving strange aerodynamic dunes called yardangs. These wind-sculpted yardangs form long, parallel ridges of hardened sand and volcanic ash that align perfectly with the prevailing wind direction. By studying the orientation of these ridges from satellite images, researchers can map how wind patterns have circulated inside the canyon over millions of years, providing a detailed record of Martian atmospheric circulation. This brings us to one of the most exciting mysteries currently being investigated by researchers around the world: the search for present-day liquid water. For a long time, the scientific consensus was that liquid water simply could not exist on the surface of modern Mars because the air is too cold and the pressure is too low. Every drop was thought to be locked away as dry ice at the poles, frozen permanently into deep permafrost, or lost to space billions of years ago. Yet during warm Martian seasons, orbiters have spotted strange dark streaks that appear on the steep, sun-facing slopes of these canyon walls. These features are known as recurring slope lineae, or RSL for short. They begin as narrow dark fingers on rocky cliffs, grow longer during the warmest months of the year, and then fade away when the temperature drops back down during the Martian winter. Many planetary scientists believe these dark streaks might be caused by trickles of extremely salty water, known as brines, seeping out from underground reservoirs trapped within the canyon walls. Salt lowers the freezing point of water, allowing it to stay in liquid form even in freezing temperatures, much like salt keeps icy roads clear on Earth during freezing winter storms. Magnesium and calcium perchlorates, which are abundant in Martian soil, can keep water liquid at temperatures far below the normal freezing point. If these streaks truly represent salty water flowing on Mars today, it means that the deepest parts of this canyon are not just ancient relics of the past. They could be active, dynamic environments where liquid water still interacts with the soil in the present day. That realization has completely revolutionized how NASA and other international space agencies plan future exploration missions. Do you believe that microscopic life forms could be surviving right now inside these salty underground trickles on Mars? What do you think alien microbes would look like if we found them under a microscope? Share your theory in the comments right now, and make sure to subscribe so you stay updated on every new discovery our rovers make. Scientists originally thought that if underground water existed on Mars, it would be buried miles beneath flat plains where drills could never reach it. But inside this massive canyon system, natural forces have already done the heavy digging for us. The canyon has sliced thousands of feet into the crust, exposing deep underground layers that would otherwise be completely hidden beneath solid rock. This makes the canyon walls the absolute best place in the entire solar system to look for biosignatures, which are chemical traces, organic molecules, or microscopic fossils left behind by ancient microbial life. If life ever existed on Mars when the planet was warm and wet, its remains are likely preserved inside the sedimentary muds and clay minerals that line the base of these colossal cliffs. On Earth, we find extreme forms of life, known as extremophiles, living inside the darkest and most hostile environments imaginable. Microbes thrive deep inside volcanic vents at the bottom of the ocean, inside ancient salt crystals buried under deserts, and even trapped within Antarctic ice sheets that have been frozen for millions of years. If life on Earth can survive in such harsh places, there is every reason to believe Martian microbes could have adapted to survive inside the sheltered basements of Valles Marineris. Some scientists hypothesize that endolithic organisms, which are bacteria that live inside the microscopic pores of solid rock, could be thriving within the sandstone and clay layers of the canyon. These organisms would be completely shielded from surface ultraviolet radiation, feeding on chemical energy released by the interaction between minerals and trace amounts of moisture. However, exploring a canyon of this size presents immense technological challenges. You cannot simply land a traditional rover with parachutes and retro-rockets onto a steep, jagged cliff. The winds are unpredictable, the slopes are dangerously steep, and the terrain is covered in massive boulder fields from ancient rockfalls that could crush a lander in seconds. A single wrong gust of wind could slam a billion-dollar rover into a vertical rock wall. To solve this problem, engineers at NASA's Jet Propulsion Laboratory and various aerospace research centers are designing new types of exploration vehicles. Instead of relying only on heavy-wheeled rovers like Curiosity or Perseverance, future missions may deploy autonomous flying drones, robotic cliff climbers, and gliding probes that can soar along the canyon walls and sample rock layers directly. Following the incredible success of the Ingenuity Mars helicopter, which flew over 70 times in the thin Martian air and exceeded all expectations, scientists realized that aerial exploration on Mars is fully possible. A larger, solar-powered drone, or an autonomous glider, could ride the thermal updrafts created by the canyon walls, gliding for hours without using much battery power. Imagine a fleet of autonomous robotic gliders riding the warm thermal updrafts inside this Martian valley, swooping down into shadowed ravines where no sunlight has reached for millions of years. They could scan rock faces with lasers, drop miniature sensor pods into deep crevices, and send high-definition video back to Earth in real time. These drones could explore areas where no wheeled machine could ever roll, covering hundreds of miles of cliff faces in a single mission. In addition to drones, roboticists are developing spider-like rappelling robots equipped with titanium gripping claws and drilling anchors. These machines could secure themselves to the top of a cliff and slowly lower themselves down the vertical rock face, analyzing each layer of stone as they descend. They could drill directly into the RSL streaks to test for active microbial life without contaminating the samples with earthly bacteria. Which type of explorer would you build if you were in charge of NASA? A flying robotic glider that covers vast distances, or a climbing robot that drills deep into vertical cliffs? Leave your vote in the comments section below, and if you are finding this fascinating, smash that like button to keep this mission going. Another incredible feature hidden within Valles Marineris is the labyrinth of Noctis Labyrinthus, which translates to the labyrinth of night. Located at the western end of the canyon system, this is a chaotic network of deep, intersecting valleys, flat-topped mesas, and narrow canyons that look like a giant maze carved into the surface of the planet. It sits right where the canyon system meets the volcanic Tharsis Plateau. Scientists believe Noctis Labyrinthus was formed when underground magma chambers emptied out during massive volcanic eruptions, causing the unsupported ground above to fracture and collapse in every direction. The resulting landscape is so confusing and rugged that an astronaut trying to navigate it on foot would easily become lost among towering stone pillars and sheer drops that extend for hundreds of miles in every direction. Recent data from European orbiters has shown that the valleys of Noctis Labyrinthus contain extensive deposits of volcanic ash mixed with clay minerals and hydrated sulfates. This indicates that even after the ground collapsed, geothermal vents and hot springs were active here, creating warm, moist pockets that could have served as ideal habitats for ancient life long after the rest of the planet turned cold and dry. These geothermal vents would have acted like natural planetary incubators, keeping water warm and circulating mineral-rich fluids through the soil. On Earth, hydrothermal vents are considered by many biologists to be the exact places where life first began on our planet. Finding evidence of similar volcanic spring systems on Mars makes the Labyrinth of Night one of the most exciting targets for future astrobiology missions. Furthermore, scientists have discovered evidence of ancient glacial valleys tucked away within the higher branches of the canyon. Long ago, when the tilt of Mars's axis was different than it is today, massive glaciers of water ice flowed down from the surrounding plains into the canyon depths. These glaciers carved out smooth, U-shaped valleys and deposited giant ridges of rocky gravel known as moraines. Some of these ancient glaciers may not be entirely gone. Radar scans from instruments like SHARED on NASA's Mars Reconnaissance Orbiter indicate that beneath a protective layer of thick red dust, vast sheets of pure water ice may still remain frozen inside the canyon walls. The dust acts as an insulating blanket, preventing the ice from sublimating directly into the thin Martian atmosphere. This means that future human settlers might have access to trillions of gallons of fresh water stored right inside the canyon walls. When human explorers finally set foot on Mars, establishing a colony near these hidden ice reserves could solve their most critical survival challenge. Water is not only essential for drinking and growing food in pressurized greenhouses, but it can also be split into hydrogen and oxygen using electricity. The oxygen provides breathable air for habitats, while the hydrogen can be used as rocket fuel to power the return journey home to Earth. The presence of accessible water ice fundamentally changes the economics of space exploration. Transporting heavy water from Earth to Mars costs millions of dollars per ton. If astronauts can simply mine water ice directly from the canyon walls using automated melting systems, human missions can become self-sustaining and significantly safer over long durations. Would you be willing to leave Earth behind and spend the rest of your life living in an underground research base inside a Martian canyon? Think about what the daily life would be like, looking up at 2-mile-high cliffs every morning, and tell me your answer in the comments below, along with hitting the subscribe button to stay connected with our space journey. Beyond water ice and volcanic minerals, the deep canyon walls also expose vast deposits of iron oxide and clay minerals that could provide building materials for a permanent Martian colony. Astronauts could extract iron directly from the rock to manufacture steel beams, tools, and habitat structures using 3-dimensional printing technology. The red planet itself contains all the raw elements needed to construct a new civilization. The thermal stability of the canyon floor is another huge advantage for human survival. On the open plains of Mars, temperatures fluctuate wildly between day and night, swinging from comfortable room temperatures near the equator at noon down to minus 100 degrees at night. Inside the canyon, the massive stone walls absorb heat during the day and slowly radiate it back out during the night, buffering against the extreme temperature swings and making temperature control inside habitats much easier. Furthermore, the canyon floor provides natural protection against planetary dust storms. While the global dust storms can block out the sun across the entire planet, the thick walls of the canyon help reduce wind speeds at the bottom, preventing habitat structures from being sandblasted by high-velocity dust particles. This natural shielding could extend the operational lifespan of solar panels and delicate mechanical equipment. When we zoom out and look at the bigger picture, studying the massive canyons of Mars is not just about understanding another planet. It is about understanding our own home and our place in the cosmos. Mars and Earth started out around the same time, formed from the same cloud of gas and dust that orbited our young sun more than 4.5 billion years ago. In their early days, both planets were warm, wet, and active. Both had thick atmospheres, raging volcanic systems, and liquid water flowing across their surfaces. But somewhere along the way, their paths diverged dramatically. Earth maintained its protective magnetic field, kept its oceans, and became a thriving cradle for complex life, while Mars lost its magnetic shield, saw its atmosphere stripped away by solar winds, and dried out into a cold, silent desert. By exploring the giant fractures and exposed layers of Valles Marineris, we are essentially looking at an alternate timeline of our own world. We are studying what happens to a rocky planet when its internal engine cools down and its oceans vanish into the void of space. It teaches us how fragile planetary environments really are, and how precious Earth's stable climate and magnetic shield truly are for our continued survival. Every high-definition photograph sent back by our orbiters, every laser measurement taken from space, and every new geological map brings us one step closer to answering humanity's ultimate question. Are we alone in the universe, or did life once spark on our neighboring world? The answers are waiting for us, carved into the sheer, towering cliffs of a canyon so vast it defies human imagination. As space agencies and private companies push closer to launching the first crewed missions to Mars in the coming decades, the wonders of Valles Marineris will undoubtedly be at the top of their exploration list. One day, human boots will kick up the red dust on the canyon floor, and human eyes will gaze up at rock walls that touch the edge of the sky. Until that day arrives, our robotic eyes in the sky will continue to map every crevice, monitor every dust devil, and search for the quiet signs of ancient life hidden within the red rock. Every new scan reveals that Mars is not a static museum piece of dead stone, but a world with complex weather, shifting geology, and deep mysteries waiting to be solved. If you enjoyed uncovering the secrets of this colossal Martian chasm, make sure to subscribe to the channel, click the notification bell so you never miss an upload, drop a comment letting me know what space mystery we should explore next, and share the story with anyone who looks up at the night sky in wonder. Thank you so much for watching, and we will see you in the next exploration.